Shriya Bansal, and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, we are actually going to talk about the C-scan scheduling algorithm, and after that, we will talk about the look scheduling. Okay, so before actually understanding C-scan scheduling, what we'll do is we'll quickly take a rewind and understand scan scheduling. Okay, so what used to happen in the scan scheduling was that you used to pick a direction, okay, and you used to move into that direction till the very end, right? And then after reaching to the very end, you used to move in the other direction and process the request in that direction, okay. But the problem with that kind of approach is, right, the request which is just after where your current I would say head is, right, they would be more easier to get processed, and the request which is just before, okay, the head, it will take a lot of time to process that request, okay. So it was kind of unfair to a few processes which are just arriving before where your head currently is in the opposite direction, and it was very favorable for those processes which are currently in the same direction, okay. So that is why we introduced the idea of circular scan, okay, which is nothing but a variant of scan only, which is designed to provide a more uniform wait time and provide a slightly fair chance for the processes to get their request executed. So like scan, the C-scan also moves the head from one end of the disk to the other end of the disk, okay, and it basically services the request along the way, okay. But when the head reaches the other end, okay, it immediately returns back to the very beginning, okay, without basically servicing any request on the return trip, okay. To understand it the best way possible, what's the usual thing when you board a flight, right? Let's say there is a flight which is going from Delhi to Bangalore, okay, and it is going to take some passengers along with it, right? And when it will reach Bangalore, again it will board some passengers on the plane, and those passengers will now come to Delhi, okay. That is scan. What is C scan? That you board some passengers from Delhi to Bangalore, right, and you basically reach the destination, and from Bangalore to Delhi, right? That means coming back to the very start of the disk again, or very start of your source again, the plane comes empty, okay? It does not takes any passenger, and then from Delhi to Bangalore, it takes the passengers again. So it's pretty much something like that only. So when we were having scan, sorry, when we were having scan, we were processing requests this way, and we were processing requests this way. But when we are going to use C-scan or circular scan, we are going to, let's say, process request this way and then come back over here without processing request, and then process request this way, and then come back here again empty, and then process request in this way, okay. Or it could be like, sorry, or it could also be like, let's say here it starts this way and come back again without processing any request, and that goes to the other end while processing request and then come back again. So that is the difference between a scan and a circular scan, okay. The C-scan scheduling algorithm essentially treats the cylinders as a circular list that wraps around from the final cylinder to the first one, okay. So it's like a wrapping. You've kind of considered cylinders to be in a circular format, okay. So that was the overall idea. Yes, let's take an example. So here we have 98, 183, 37, 122, 14, 124, 65 and 67. And the head is at 53. So if the head is at 53, it will go to 65, 67, 98, 122, 124, 183, 90, 199 and just simply comes back and does not process any request. And then again goes to 0 and then goes to 13. Goes to 14 and then goes to 37, okay. So that is how it's happening. It's going this way and then coming back all the way to the start and then processing the request again in that manner, okay. So let's take an example over here also in this terms for C-scan to learn this concept in a slightly better way and using the examples we've already seen. So what all requests did we have? We are going to take the same ones which we have already, which was 82, 170, 43, 140, 16, 190. Okay. And here the arm is basically at, let's say, 50. Okay. And here what we are doing is we are always moving towards the larger value. So here if it is something like this, 0, 16, 23, 43, 50, 8200, 140, 150, 170, 190 and 199. So how will that work is, if we are at 50, okay, we'll first go to 82, then we will basically go to 140 from here, then we will go to 170 from here, 190 from here, and then till the very end. Okay, and after that we will come all the way till here, and then we will process the request 16, we'll process the request 24, and then we'll process the request 43. Okay, so how will the total seek time over here will work basically would be that first we went from what, 150 to 199. Okay, then we went from 199 to 0. Okay, and here it is this. So here the total, I would say, seek time here would be 391. Okay, which is actually slightly, I would say, greater than the one which we have already seen. Okay, so let's talk about a few advantages and disadvantages also of this kind of an approach. So I think in scan, we basically got 332, right? This was for scan only, right? And for C-scan, we actually got 391. So first of all, a few advantages and the disadvantages. Okay, it basically works well. This kind of a algorithm works well where there is moderate to heavy load. For very low load, you might not prefer this algorithm. That is the first advantage. The second advantage is that it performs better response time. Okay, and there is a uniform waiting time. That's what the best thing is, that the waiting time is actually uniform and not non-uniform, wherein some processes waiting a lot, whereas the other processes, not waiting all together. Okay, so it basically performs, I would say, better waiting time or provides more uniform. In fact, even in response time is just for FCFS. Response time is actually better for scan. But I feel here the better point to put it, that here it provides more unifying wait time. Okay, compared to scan. Okay, so these are the advantages of using C-scan. Okay, but the disadvantage of using C-scan is that sometimes it's actually may not be fair, okay, to service those requests for the tracks that are at the extreme end. Okay, there are some requests which are at the extreme end. Now that might be a little bit disadvantageous over here because we are moving end to end. Okay, and here obviously it has comparatively more seek time. So I think one of the major disadvantage over here is that it has more seek time compared to scan. Okay, so that's what the overall idea is whenever we try to understand the C-scan algorithm. Okay, so next what we'll do is we'll now talk about the look scheduling. So what happens is practically scan and C-scan algorithm are not actually implemented the way we just I would say talked about. Okay, so what really happens is look is basically very similar to scan scheduling only, except for one difference, that the disk arm is simply going to the very end, like very end of the disk, and it goes only to the last request. Okay, so here what you are seeing is that whenever we have a request to process, right, we're actually going towards the very end. You can see in this example that here when we were using scan, my last request was actually till 190, correct? Still I am basically doing this kind of I would say processing, right, where I am actually going to the end of the disk. So what do we do in look is, instead of going towards the end of the disk, we actually till go to the end of the request, last request, and simply turn from here only instead of turning from here. Okay, that's what the only difference between I would say scan and look exactly is. So it kind of prevents some extra delay, okay, because it might happen that the last is 199 but your last request was 170. Still you would have gone 20 over here, right, which was not required. So kind of I can say prevent I can actually be used to look can actually be used to prevent some extra delay which is basically caused due to unnecessary traversal to the very end of the disk. Okay, so that is what it says, that more commonly the arm of the head disk basically goes only as far as the final request in each direction. Then it simply reverses direction immediately without going all the way at the end of the disk. Okay, this version, so this version of scan is known as look, and this kind of a version for C-scan, where in C-scan also you don't go to the very end, would known as C-look. Okay, because they are basically looking for a request before continuing to move into a certain direction instead of looking for the end of the disk. Okay. All right. Again, the same example. Here also we are taking same examples for 98, 183, 37 and all. And here the head of the cylinder is 53. So now you will see is we are just going, the last request is till 183. So that's why we are going till 183. But if you will look at scan, in scan, right, what we were doing was we were actually going from 14 till the very 0 as well. Okay, which was not required. From 14, you could have directly moved to 65. That is what I have done over here. Whereas from 180, since here the direction is a little different, where from 183, we are not going to 199 and directly shifting to the next request. Okay, so that's what it works over here. Let's also take the same example we took over here as well. For look also so far we have taken, so that we can actually very much do a quick POC on the understanding of what we have learned. So in the look also, we'll take the same example. The request will be the same, 82, 170, 43, 140, 24, 16, 190. Okay, and here the head is basically at 50. And here we start with 0, 24, 43, 50, 82, 100, 140, 150, 190, 199. Okay, so here what we do is we are 82. We are at, here we are at 140 first. Then we are at 170. Then we are at 190. And then we directly basically jump over here. Since it's look, so we'll follow C look. So we have to process request on every way. Then we go directly to 43. Okay. Then we go to 24 and then we go to 16. Okay. So that's what the process is that we follow over here. So what is the seek time? In this case, the seek time would be 190 minus 50 plus 190 minus 16, which is 314. Definitely a better optimization over the simple scan. Okay, so that's what the overall idea is about the look scheduling over here. Okay, now definitely look scheduling is something better that we are doing on top of scan. Okay, so basically there are no as such, like I would say, advantage or disadvantage in this perspective, because look is basically a better way of implementing scan. Okay, so whatever points are applicable there are applicable here as well, with just one small modification that we kind of prevent some delays in look which we were doing in scan. Okay, So with this, I hope everyone understood all the scheduling algorithms that we discussed. There are some more algorithms as well. Okay, this is not the end of it, right? We have some more scheduling algorithms available also, right? We have LIFO, we have N-step scan, we have FSF scan, or many are available, but these are the most popularly used scheduling algorithms. Okay. Now, what happens is when you know so many algorithms, one of the very common questions that can come to your mind over here is, how do we select a disk scheduling algorithm? How do we know in what situation which scheduling algorithm is better? So that has kind of like a perspective over here where there are certain situations that have been considered, and for certain situations we usually have a particular algorithm that fits really well. Okay. For example, shortest seek time first is very common algorithm, and it has a very natural appeal to it as well, right? It has a very natural understanding. The processes which have shorter seek time would be allowed to execute first, right? And then the processes after that. Scan and Skiscan are basically performing better for systems that have heavy load on the disk. Okay, so if you have a disk which has a heavy load, right, which has a lot of incoming requests at a very high rate, in that situations you want to make sure that there is a uniform distribution of requests and there's no starvation situation as such. So then you can prefer either scan or Cscan, right? Also, the performance not just depends on these algorithms, but it's highly dependent on the number of types and requests. So you should also take into consideration that part as well whenever you are selecting a disk scheduling algorithm. Apart from that, requests for a disk service can also be influenced by the file allocation methods as well. So there are multiple, I would say, file allocation methods, I would say, which are available, which kind of influence the way, right? I would say influence the way how we process the request, right? Which leads to the idea that this happens. So whenever we are doing file allocation, there could be a continuous allocation, linked allocation, index allocation, right? There are different methods available, right? And based on that, we basically try to influence, right? Or we try to take care of the disk scheduling algorithm that we pick. Okay. Again, the fifth point being that the disk scheduling algorithm should be written as a separate module of the operating system, allowing it to be replaced with a different algorithm if necessary. So the thing is, even if you pick the operating system, even if you pick an algorithm, the scenario changes a lot. The business use case changes a lot. Earlier, you might have a situation where the load was very low, so you picked up SSTF, but then the load increased very high and now you want to pick up scan. So we should always have the code very modular. That means if in future I want to replace an algorithm, I should have the capability to do that as well. Okay, so usually either SSTF or Look is a reasonable choice if you have to pick up a default algorithm, and there should always be a use case where you can override these algorithms with different algorithms as and when you like. Okay. So that's what pretty much the overall idea is about disk scheduling, about different types of disk scheduling algorithms which are available, and what should you keep in mind while doing the selection for disk scheduling algorithms. Okay, I hope it is clear to everyone. The best way to understand and learn these topics is to practice itself. So make sure you do practice a lot, right? And you do get a better grasp on these topics, and they will help you a lot for better scaling of your understanding for these topics and your learning as well. Okay, so make sure you keep that in mind. And with that, I think we can move ahead to the next section of secondary storage management in the next video. Thank you so much for taking a look. Thank you.